Hi everyone, in this video we're going to look at continuous random variables. A continuous random variable differs from a discrete random variable in the sense that it takes on an uncountably infinite number of possible outcomes. That is, a continuous random variable can take any value within a certain range. For example, we have height, we have weight, we have time. All these values can take any value within a certain range. For example, between 20 and 30, you can have different values. For example, 20.5, 20.6, 25.9. The probability density function, PDF of x, f of x, gives the probability for which x lies within a certain range. The PDF f of x is well defined for x lies between a and b if we integrate between a and b, f of x dx equals 1. When we did a discrete random variable, to check whether the random variable x is well defined, we took summation of all x, p of x is equal to x is equal to 1. So here we are dealing with continuous random variables and we use integration to find probabilities. That is, we are finding the area under the curve from a lower limit a to an upper limit b. So if we integrate from lower limit to upper limit, we are going to get 1. As you can see in this diagram, we have a function f of x which is valid from lower limit a to upper limit b. So if we need to find the probability from a to b, we simply integrate the function from lower limit a to upper limit b. So basically, probabilities are given by the area under the curve. The first graph shows a function valid over a range from a to b. And if we integrate the function from the lower limit a to the upper limit b, we should get 1. That is, the area of the shaded part here is 1. Since we are integrating all values of x, that is, here it represents that the function is well defined since you are integrating from a to b, for which this function is valid. The second diagram shows the function f of x valid from a to b, and here we need to find the probability that x lies from x1 to x2, where x1 and x2 lies between a and b. So we are simply finding the probability of this shaded area here. So to find the probability of x lies between x1 and x2, that is, to find the probability of the shaded part, we simply integrate from x1 to x2 the function f of x with respect to x. The probability of x lies between a and b inclusive is the same as x lies between a and b, where a and b are not included. It's the same as x lies between a and b, where a is included. It's the same as x lies between a and b, where b is included. So whenever you are dealing with continuous random variables, you need to focus only on a and b. So if you're asked to find a probability between a and b, we simply integrate from the lower limit to the upper limit without taking into consideration the inequality signs, which is different from a discrete random variable where we do consider the inequality signs. Let's see the difference between the discrete and the continuous. Suppose you're asked to find the probability of x. So if we are dealing with a discrete random variable and we are asked to find x lies between 2 and 5, where 2 is inclusive, we're going to take the probability of what? X is equal to 2 plus x is equal to 3 plus x equals to 4. But if you are dealing with a continuous random variable x and you're asked to find the probability that x lies between 2 and 5, where 2 is inclusive, we simply take into consideration the lower limit and the upper limit. So we integrate from lower limit 2 to upper limit 5 the function f of x with respect to x. This probability is going to be the same as probability of x lies between 2 and 5, which will be the same as probability of x lies between 2 and 5, which is the same as x lies between 2 and 5. So all these probabilities will give the same integral. Next, if we integrate the function from negative infinity to infinity, we get 1. The expectation is given by integrate from negative infinity to infinity x times f of x dx. Expectation of x squared is integrate from negative infinity to infinity x squared times the function with respect to x. The variance is expectation of x squared minus the mean to the square.